All right, hello, and welcome to some NTI, some non-traditional instruction. Uh, this is my first go at trying it on OneNote and with the Xbox Game Bar, using the tools I have. I hope you all are doing well. You're staying active physically and mentally, and you're practicing healthy social isolation. I have a feeling that we might be in hermit mode for a little bit longer than expected. If that does end up happening, I wanted to try out this screen recording and showing you all some trig that we started when we were last in school. So with your homework that was due and is probably due in hopefully 3 weeks, the first set of matching is a little funky. When it comes down to 15, if we start here, we got our options up there, but 15 has a trig identity for secant to start off with. If you remember last time, we looked at how to write these starting at the top and working down, and then we had the option to simplify using trig identities or algebra, and I started off with trig by using a reciprocal identity, and it's pretty easy to see which one I'm going to sort of cancel out there. I get 1 with the reciprocal of cosine multiplying by cosine, we get 1. And then moving on to tangent and cosecant, here I'm going to turn everything into sine and cosine. And remember, the whole point of this is to manipulate the trig functions here. And it really just shows what sort of flexibility you have with these rules if you can manipulate them. So we're going to get secant of x here, and then cancel that one off my list. Remember last time we went through some of these algebra, we practiced with these algebra techniques there at the bottom, those basic algebra operations, and then we also had the special trig identities of reciprocal, quotient, Pythagorean. This one over here looks like a Pythagorean identity, and I'm going to try and make this video rather quick, but it looks like the cotangent and cosecant squared should have an identity attached to them. If you can't remember which one does what, remember you can always start off at sine squared x plus cosine squared x equals 1, and you can think, well, what do I divide all this by to get maybe cotangent or cosecant? And it's definitely going to be sine squared on both sides. So I'll do that, and I'll get 1 plus cotangent squared x equals cosecant squared x. And it looks like if I can rearrange these properly, I should be okay. So I'll keep my cotangent squared x on this side, and I'll subtract cosecant squared from it. And then I'll move my 1 as well to the right side of that equation. Now, this is an equation over here. That means that -1 is equal to cotangent squared x minus cosecant squared x. So I can just replace what I see in this simplify trig identity problem to be -1. There we go. And if I move along here, I bet I could get 18. I bet you can too. Let's look at something a little bit more challenging with 19 and 20. I didn't give you these trig identities, but I'd like you to use your idea of you remember that pink page we did abstract angles? Well, what if we represented angles abstractly here as well? So I take x and I just place it as a positive angle, and then I represent negative x, kind of how it would appear as the negative form of itself. And if I take sine of negative x, if I take sine of negative x, won't that give me a negative sine? So sine of negative x is going to be equal to sine of x. Sorry, negative sine of x. So if we look at these functions, or these, angles, y values, I've got a positive y value for positive x, but if I were to look at the sine value for negative x, let's just say this is, I don't know, we'll just say it's negative radical 3 over 2. We'll say this is like a negative 60-degree angle, 1/2. Then it would only follow that in order to make a positive angle's sine value, negative is just to multiply that value by a negative 1. So here this idea is going to stand true. So if we look at a cosine version of this same idea, cosine of negative x, it doesn't look like cosine's value changes, because remember, it's x. It's just the x distance on this triangle. So if we're only looking at the x distance along this triangle, let me just use a different color here, blue, another kind of blue, then that x distance doesn't change. So it's going to remain a positive value. So basically, cosine of negative x is the same thing as cosine of positive x. And I know I might have lost some of you on that one. If it can be reasoned out for you, that would be the best way to do it, is to represent it visually. And then you can simplify from there by taking negative sine x as the numerator to this problem now, because they're equal again, and then you can take cosine of negative x to be cosine of x. Now I am kind of pushing a few limits here. I'm trying to see what my computer can take, and how many people I've just lost, because I've went a little bit longer than I wanted to, at 8 minutes now. But I do see that I have my answer to this problem. I got negative tangent x. Okay, cool. So I can cross that one out. Hopefully we can get, I can cross out b as well. Hopefully we can get the other two, just if you can get 18. So with the exception of 19 and 20, which require a lot of reasoning, similar to this that I've just highlighted there in blue, you can definitely get those. And then, of course, the rest of the homework is here at the bottom. There's our notes from last time. And you can try that with the means you have right now. If you can't access this video on Google Classroom, then obviously you wouldn't be hearing this, but I'll try to make it available in different ways. And if you can hear this, please let me know if there are any suggestions you might have. The time length, the quality of the recording, what was helpful, what was not. Do you just want to see homework right now? In the future, if anything changes, I will be trying to attempt this method again, and I want to see how it goes. So let me know. Hope you're all doing so well. Bye.